Today, I want to talk about two manufacturing processes. One is a conventional manufacturing process, a high-pressure die casting. Another one is an advanced manufacturing process, vacuum-assisted high-pressure die casting. I will briefly introduce the main features of two processes, the advantage and the shortage, the risk and cost, and the currently usage of two techniques. I will state why the company should build a vacuum-assisted high-pressure die casting production line instead of a conventional high-pressure die casting production line. Firstly, let's talk about high-pressure die casting. High-pressure die casting, also called PHDC, is a very commonly used process for creating structural components. In this process, a metal die having a cavity with the negative geometry of the part is created. Simple die usually consist of two matching halves, while more complex dies can add sliding features that create holes and undercut areas. Here are some advantages and disadvantages of this process. It has short casting circles. It is suitable for thin-walled components, and it can produce smooth surface components, and it is well suited to automotion. Based on those advantages, the mass production sector was focused to continue with high-pressure die casting because of its extremely fast cycle times. The fact is that a high-pressure die casting machine costs around 4 times as much as a low-pressure system until a few years ago. However, the former's casting cycle were around 4 to 6 times faster. This advantage makes it a commonly used manufacturing process. It also has some disadvantage. It has high investment and operating cost. It is complicated and expensive. And it produces low strength volumes. Also, die casting weight limited by the locking force of the machine. These limitations abase the commercial value of a high-pressure die casting production line. However, a new technique, vacuum-assisted high-pressure die casting, is invented, improving some drawback of traditional high-pressure die casting. With a vacuum-assisted system, a vacuum is drawn in both the chute sleeve and the mold cavity before the injection chute occurs. Almost all air is positively evacuated from the mold and the vacuum is maintained until the injection cycle is completed. Vacuum-assisted die casting decisively reduces gas porosity in the casting. This significant reduction in the volume of gas porosity and the pore size in casting has the result of markedly improving the density and tensile strength of the end product. As we know, one of the main causes of porosity in die casting parts is trapped air or gas that may occur due to the process principle during conventional cold chamber die cast process and cannot be avoided even by good venting. In conventional die casting, the air and gases in mold cavity are pressed into the overflow and the venting channels. However, there are still leftovers after this process, or the pressure in the mold may increase already in the first place by 1,500 to 3,000 bar depending on the venting application and plug velocity. In the second phase, those volume may be doubled or tripled. By means of evacuation of the mold cavity when using a vacuum system, the gas pressure increase can be avoided. Rarely, they exceed 200 bar. A good vacuum in the mold cavity enables the airline to flow into blind recesses in complex shapes. It also allows the forms of the molded metal to merge freely without forming shots. Vacuum-assisted die casting offers benefits beyond simply reduced porosity. It also offers several technique advantage, like prevention of air entrapment, prevention of burning marks, prevention of shrink marks, increased surface equality, improved static, mechanic, and dynamic properties, production of die casting parts for heat treatment. Vacuum alone will not make a casting system more efficient. Vacuum supplements the efficiency of a well-designed casting process and extends its capability. Although it also has some disadvantage, like high investment and operating cost. It also has complicated, expensive dies. But I would say, if a company can produce high quality of products without facing new difficulties, there's no reason to refuse to build a new vacuum assisted high pressure die casting production line.